what truly lies beneath the clouds of Venus. For centuries, it has hung in the heavens as a golden lantern, a shimmering jewel against the dark velvet of night. To the human eye, it was beauty itself, a world wrapped in soft brilliance, forever cloaked in mystery. Early dreamers imagined oceans gleaming beneath its haze. They pictured jungles teeming with strange life, or even civilizations waiting to be discovered. Venus was the twin of Earth, so how could it not share our familiar warmth, our waters, our breath of life? But science has pulled back the curtain, and what it revealed defied those ancient hopes. Beneath the golden veil is not a paradise, but a furnace. The air is thick with carbon dioxide, crushing down with a pressure strong enough to flatten steel. The clouds are not water vapor, but sulfuric acid drifting in a choking haze. The ground burns at temperatures hot enough to melt lead, a heat that never fades, locked in by an endless greenhouse effect. Venus is a vision of beauty, yet a reality of ruin. A place both alluring and merciless, where even the strongest machines falter and die after only hours on its surface. Still, the question remains. What else hides beneath those clouds? What secrets lie in the shifting winds, in the fractured plains, in the volcanic scars that mark the land? What we have finally seen is stranger, harsher, and more mysterious than we ever dared to imagine. For as long as humanity has lifted its gaze to the heavens, Venus has been there. The morning star, the evening star, a radiant presence that outshines all others except the sun and the moon. It appeared as a beacon of rhythm and recurrence, always returning to the sky with a loyalty that inspired wonder. In ancient Mesopotamia, it was Ishtar, the goddess of love and war. To the Maya, it was Kukulkan, a divine serpent whose rising foretold the fate of kings and kingdoms. In Greece and Rome, it became Aphrodite and Venus, symbols of beauty and desire. Across cultures, its brilliance shaped calendars, rituals, and mythologies. No other planet so firmly bound the celestial to the human imagination. And yet, for all its brightness, Venus withheld its truth. The more it was admired, the less it revealed. Through early telescopes, Galileo discovered that Venus, like the moon, passed through phases. A glowing crescent, a half-disk, a full orb of light. Proof that it circled the sun, not Earth, but beyond that, no detail emerged. The planet's surface remained hidden, locked away behind a veil so perfect that centuries of astronomers saw only light, never land. That veil was its atmosphere, a shroud of clouds thick enough to obscure even the sharpest glass. Made not of water vapor, but of sulfuric acid, these clouds reflected sunlight with dazzling brilliance. To the human eye, Venus appeared flawless, golden, and smooth. But this beauty was only the face of concealment. Every effort to pierce its mask failed, leaving astronomers with a blank canvas on which speculation could run wild. Some imagined oceans stretching across its surface, heated by perpetual sunshine but moderated by cloud cover. Others envisioned vast jungles steaming with life, an earthly paradise hidden in perpetual twilight. Still others wondered if civilizations might thrive beneath the clouds, unseen, yet perhaps watching us in return. Venus became a mirror of imagination, reflecting not its own truth, but the hopes and fears of those who studied it. Science, however, was relentless. As instruments grew more powerful, new clues emerged. Spectroscopic analysis of Venus's light revealed a thick atmosphere rich in carbon dioxide. The planet's mass and density suggested an Earth-like composition, a rocky body with similar gravity and structure. To some, this only deepened the fascination. If Venus was Earth's twin in size and form, could it also be its twin in life? If it was born of the same cosmic dust, molded by the same stellar furnace, why should it not share our oceans and continents, our storms and seasons? But there was a problem of perception. Telescopes showed nothing. Instruments hinted at contradiction. Evidence remained elusive. And in the absence of certainty, speculation flourished. For centuries, Venus was less a planet than a canvas of dreams. Theories rose and fell, built on fragments of data, only to dissolve in the face of new mystery. It was a world both near and unreachable. A planet so bright it could cast shadows on Earth at night, yet so secretive it refused to surrender its face. An enigma suspended in the sky, daring us to guess at its truth. And so, generation after generation, humanity watched the morning star rise and fall, never knowing what lay beneath its golden glow. It was a reminder that sometimes the most dazzling mysteries are not hidden in distant galaxies, but shining close to home, waiting for the moment when science finally learns how to see through the veil. The veil of Venus could not be lifted by human eyes alone. For centuries, telescopes stared and failed, their lenses powerless against the opaque clouds. Yet in the 20th century, a new kind of vision was born. Humanity had learned to see without sight, to map the invisible through the echo of signals. Radar astronomy became the first key to unlocking the hidden face of Earth's sister world. In the early 1960s, powerful radio waves were sent across the void. They struck Venus's atmosphere, then scattered, reflected, and returned as faint whispers of information. These echoes were distorted, blurred by the dense air and swirling winds, but within them lay a truth. Venus was not a water world. It was not a paradise veiled in mist. The surface reflected radio signals as if it were hard, dry, and solid. A planet of rock, not ocean. A furnace rather than a garden. This revelation marked the first fracture in centuries of hopeful speculation. But radar could only sketch outlines, rough maps of elevation and texture. The true face of Venus remained hidden. To pierce the veil more deeply, machines would need to descend through the clouds themselves, to touch alien soil, and to endure the punishment of a world more hostile than any imagined in myth. That challenge was embraced by the Soviet Union. No nation was more determined to conquer the unknown face of Venus than the engineers of the Venera program. Across decades, they launched a fleet of robotic emissaries, each one hurled into the shrouded world with a single desperate mission: survive long enough to tell humanity what lay beneath the clouds. Their struggle was relentless. Venus was no passive host. It fought against every machine that dared to land. The descent alone was an ordeal. Parachutes strained against thick air that slowed them to a crawl. Heat shields glowed as they battled temperatures that soared higher with every kilometer. Instruments rattled beneath crushing pressure, as if the weight of an ocean were pressing down on them. Most did not make it. Some were silenced before they touched the ground, crushed or overheated in the atmosphere. Others reached the surface only to fail within moments, their circuits scorched, their cameras blinded. Venus was not only a planet of fire and stone, it was an executioner, reducing humanity's most advanced technology to silence in minutes, but a few endured long enough to whisper their secrets. In 1975, Venera 9 and Venera 10 became the first spacecraft to return images from the surface of another planet. Grainy black and white photographs emerged from the static of radio transmission. They showed not oceans, not jungles, but fractured stones scattered across a barren plain. The horizon was flat, stretching beneath a sky heavy with perpetual twilight. The rocks looked sharp and alien, yet hauntingly familiar, like the debris fields left by eruptions on Earth. It was the first time human beings had seen the surface of Venus, and it was nothing like the paradise once imagined. Later missions pushed deeper. Venera 13 and 14, launched in the early 1980s, carried color cameras, soil analyzers, and microphones. They landed with reinforced armor, built to survive the furnace. Against all odds, Venera 13 endured for over 2 hours before succumbing to the inevitable. In that brief window, it revealed a world that was stark and lifeless. The sky glowed orange through a haze of clouds. The ground was littered with flat, angular rocks, fractured as though torn apart by violent geological forces. The soil crumbled under the probe's instruments, revealing a chemistry rich in basalt, evidence of ancient volcanic fire. For the first time, Venus spoke in more than images. Venera 13 carried a microphone that captured the deep, ghostly roar of wind sweeping across the surface. That sound was a revelation in itself, a reminder that beneath the silence of photographs, Venus was alive with motion. Its dense air moving in currents unseen, eroding, shaping, whispering across the plains of stone. Each mission was a battle against time. Electronics designed to endure a few hours struggled against temperatures near 465 degrees Celsius and pressures 90 times greater than Earth's sea level. Every moment that data flowed was a triumph. Every image, every chemical reading, every fragment of audio was a message smuggled out of a prison that swallowed machines whole. The glimpses revealed more than geology. They shattered illusions. No forests, no oceans, no alien civilizations watching from behind the clouds. What humanity found was harsher, stranger, and more desolate than any myth had prepared us for. Yet it was no less mysterious. The barren plains hinted at a violent history. The fractured stones spoke of tectonic stress and volcanic upheaval. The soil's chemistry suggested a world resurfaced again and again by lava flows, as if Venus had been reborn in cycles of destruction. Radar mapping confirmed vast highlands and lowlands, mountains taller than Everest, and plains that stretched for thousands of kilometers. Volcanoes dotted the surface by the hundreds, some appearing fresh, as though they might still breathe fire into the atmosphere. Venus was not merely a world that had failed to become Earth. It was a planet that had followed its own path into extremity. Where Earth's greenhouse effect nurtured life, Venus's had spiraled out of control, trapping heat until oceans boiled away and rock itself began to soften. The comparison between the two planets was no longer a matter of similarity. It was a lesson in divergence. Twins born of the same cosmic womb, yet shaped into opposites by the smallest of differences. The first attempts to see the unseen had done more than reveal barren stones. They had raised profound questions. Was Venus once like Earth, with seas and rivers before catastrophe transformed it into an inferno? Did its volcanoes still breathe, reshaping the land in secret? Could there be strange forms of chemistry, or even life hidden high above in the clouds where temperatures were less hostile? Those early missions ended quickly, each one silenced by heat and pressure. Yet together they built the foundation of knowledge. They gave humanity its first direct encounter with a world that was no longer an imagined paradise, but a harsh reality. And in that harshness there was beauty. The beauty of discovery wrestled from resistance. The beauty of hearing for the first time the winds of another planet whisper across alien stones. Venus had revealed fragments of truth, but not its full story. The veil had been pierced but not torn away. What humanity saw in those blurred images was not the end of the mystery, but the beginning of a deeper one. For if this was the reality of Earth's twin, what did it mean for the fate of Earth itself? Could a world so similar diverge so catastrophically? And if it could happen there, what lessons did Venus hold about the fragility of habitability anywhere in the cosmos? The first attempts to see the unseen had given us more than data. They had given us perspective. Venus, the morning star, was no longer just a symbol of beauty and desire. It had become a mirror of warning, showing what happens when balance tips, when a planet turns against itself. The clouds no longer concealed paradise. They concealed a cautionary tale written in stone, heat, and silence. And so, though many probes were lost, though countless machines were silenced within minutes of arrival, every signal carried weight far beyond its fragment of data. Each transmission was an act of defiance against the most hostile environment ever touched. Each photograph a testimony that even in the face of destruction, discovery was possible. The story of Venus had changed forever. What lay beneath its golden glow was no longer the dream of ancient myth. It was a world of fractured plains, volcanic scars, and a furnace that devoured steel. A world that tested the limits of endurance, yet rewarded persistence with glimpses into its harsh truth. In those first attempts, humanity had not conquered Venus, but it had taken the first step in transforming mystery into knowledge. The veil had begun to lift, and with it came the realization that what lay beneath was stranger and more powerful than imagination had ever dared to picture. For centuries, the face of Venus remained sealed behind its veil of clouds. The Venera landers had given humanity fleeting glimpses of fractured stones and barren plains, but they were fragments only. To know a world, one must map it. One must see its mountains, valleys, and plains drawn across a canvas of global scale. On Earth, explorers sailed oceans and charted coastlines. On Venus, the only vessel that could serve was radar, and the only way to draw a map was to let signals echo through the clouds. In 1989, a spacecraft was launched with a singular mission: to unveil the unseen. NASA's Magellan probe carried synthetic aperture radar, a technology capable of piercing the sulfuric haze and building images from the reflections of radio waves. For 4 years, it orbited Venus, tracing patterns across the sky, until nearly the entire planet was mapped at resolutions never before achieved. What emerged was not the paradise once imagined, nor the fractured snapshots revealed by landers, but a whole world unveiled in startling clarity. For the first time, humanity possessed a cartography of its sister planet, a map written not in myth or speculation, but in stone and scar. The discoveries were both breathtaking and unsettling. The surface of Venus was a world of volcanic immensity. Vast shield volcanoes rose higher than Everest, their flanks stretching for hundreds of kilometers. Matmons, Theamons, and others towered over the plains, their scale dwarfing anything seen on Earth. Lava had poured across the land in sheets, forming plains that covered nearly 80% of the surface. It was as if Venus had once drowned itself in fire, burying its ancient terrain beneath oceans not of water, but of molten rock. Among these volcanic fields lay structures that defied earthly comparison. Circular domes, some more than 20 kilometers wide, rose like colossal pancakes stacked upon the surface. Unlike Earth's volcanoes, which vent through narrow cones, these formations seem to have oozed slowly from beneath, creating vast, flat, rounded bulges. Scientists named them pancake domes, for there was no closer word in geology. They hinted at magmas of unusual thickness, perhaps rich in silica, suggesting a chemistry and a style of volcanism that Earth rarely experiences. Everywhere the radar looked, it found scars. Venus's surface was crossed by networks of ridges and fractures, as though the crust had been crumpled and wrinkled beneath relentless pressure. On Earth, such features are explained by plate tectonics, the grand ballet of continents drifting atop a restless mantle. But Venus showed no evidence of drifting plates. Its crust did not move in great slabs across the globe. Instead, it seemed to buckle in place, crushed and reshaped by forces from within. Whole regions were quilted with tessera terrain, fields of deformed rock, twisted and folded like fabric pressed under unimaginable weight. The absence of oceans was absolute. No riverbeds carved through the plains, no shorelines traced the edges of continents. The surface was dry, desolate, and sharp. Yet there were signs of something even stranger. The distribution of impact craters revealed a surface that was geologically young, no more than a few 100 million years old. Unlike Earth, where erosion and tectonics erase old scars, Venus seemed to have erased its past in a single catastrophic act. Many scientists came to believe that the planet had undergone a global resurfacing event, in which volcanic activity melted and repaved nearly the entire crust. If true, Venus was a world that periodically destroyed and remade itself, burying its history beneath waves of lava, leaving behind a surface both fresh and ancient, young in age but scarred by forces older than life. Magellan's radar vision revealed continents and mountains unlike any imagined in speculation. Ishtar Terra, a highland plateau the size of Australia, rose above the surrounding plains, crowned by mountains taller than the Himalayas. Maxwell Montes, the highest peak on Venus, stood nearly 11 kilometers above the surface. Aphrodite Terra, larger than Africa, stretched across the equator with canyons thousands of kilometers long, rivaling the greatest rifts of Earth. The scale was staggering. Venus was not a small twin hiding beneath its clouds. It was a world of extremes, sculpted on colossal dimensions. And yet, even with such clarity, questions deepened. How could a planet so similar to Earth in size and composition follow such a divergent path? Why did Venus lack plate tectonics, the system that cools Earth's mantle and renews its surface with continents and seas? How could it sustain such relentless volcanic activity, reshaping itself again and again? Was the planet still active? Did volcanoes still rumble beneath the haze, spewing gas into the thick atmosphere, keeping its greenhouse furnace alive? Magellan could not answer these fully, but it gave humanity the map on which such questions could be drawn. It showed patterns of fractures that suggested stress and movement, perhaps the prelude to tectonic forces unlike Earth's. It revealed volcanoes whose flows seemed fresh, hinting that Venus may not be silent at all, but alive with hidden fire. The first true cartography of Venus was more than an act of mapping. It was an act of revelation. Radar had given eyes to the blind. Where telescopes saw only clouds, where landers saw only fragments, Magellan unveiled a planet of mountains, plains, fractures, and domes. A world as dynamic and violent as Earth, but turned along a different path, a path toward isolation and heat. The images carried a haunting beauty. Smooth volcanic plains glistened in radar as dark seas of basalt. Ridges stretched across the land like wrinkles on the face of an ancient titan. Domes rose as perfect circles, silent monuments to forces no human had ever witnessed. It was a planet sculpted not by water or wind, but by fire and pressure. And in the silence of space, those maps became a mirror. They showed that Earth's twin was no paradise, no mirror of our oceans or forests. Instead, it was a vision of what happens when balance collapses. When atmosphere traps heat, when oceans boil away, when geology erupts in global catastrophe. The face of Venus was both alien and familiar, both a world of its own and a warning of what Earth could become. Magellan's mission ended in 1994, when the spacecraft was commanded to plunge into the atmosphere and burn. But it left behind a legacy of knowledge that transformed mystery into reality. For the first time, Venus was no longer a golden blur. It was a mapped world, a place of mountains, plains, volcanoes, and scars. A place harsh beyond imagination, yet alive with history written in stone. And with that map came a deeper truth. To see a planet is not only to know its geography, but to confront its story. Magellan had unveiled a world that was not static, not lifeless, but in motion. Reshaped by catastrophe, sculpted by fire, burdened by an atmosphere that pressed like the weight of an ocean. It was a reminder that planets are not fixed places, but living systems, each following its own path through the ages of the cosmos. Venus's face was finally revealed. Yet behind every mountain, every dome, every fracture, there lingered questions. Was this world still alive beneath its furnace sky? Had it once known oceans and rains before heat claimed them forever? Could life in some form cling to the clouds above, where conditions were less hostile? The first true cartography of Venus was not the end of its mystery. It was the beginning of a new era of wonder. The veil had lifted. The face had been seen. And what it revealed was stranger, harsher, and more profound than humanity had ever dared to imagine. When the maps of Venus were first drawn, they revealed not a uniform plane, but a mosaic of landscapes as alien as they were immense. Each radar echo painted contours of mountains, valleys, and plains that defied expectation. From orbit, Venus was not a world of gentle slopes or endless deserts. It was a world of broken stone, monumental structures, and scars that told of violence written into the very crust of the planet. Among the most striking features were its mountains. Maxwell Montes, rising nearly 11 kilometers above the plains, towered even higher than Earth's Everest. Yet its slopes were not carved by ice or rivers. They stood sharp and unforgiving, uplifted by forces unseen, enduring in a world where no snow could ever fall. Surrounding them stretched highland regions the size of continents, Ishtar Terra to the north, Aphrodite Terra straddling the equator, vast elevated plateaus marked with fractures and ridges. They were continents of stone without seas, land masses without oceans to embrace them. Yet even the mountains were not the strangest forms. Across Venus's surface, radar revealed structures unknown on Earth. Circular scars hundreds of kilometers wide, bordered by ridges and fractures sprawled across the plains. These were corona, immense geological features formed by plumes of molten rock rising from the planet's mantle. As the hot material pushed upward, the crust bulged, fractured, and collapsed inward, leaving behind rings of mountains and valleys unlike anything seen on Earth. Some coronae stretched nearly 2,000 kilometers across, vast enough to swallow entire countries. Their sheer scale suggested a mantle restless with heat, a world where internal fire pressed constantly against the surface. Between these giants, the land was shaped into tesserae, terrains of twisted and deformed rock, where ridges crisscrossed in complex patterns. In radar images, tesserae appeared as broken mosaics, their intersecting folds resembling the wrinkles of fabric pressed and crumpled beyond repair. Scientists believe these terrains are among the oldest surfaces on Venus, remnants that survived catastrophic resurfacing events. To study them is to peer back into a chapter of Venusian history written before the planet drowned itself in oceans of lava. And then there were the channels. Rivers without water, carved not by flow but by fire. Some lava channels stretched for thousands of kilometers, winding across the plains longer than the Nile on Earth. These immense formations suggested eruptions of unimaginable scale, with molten rock flowing across the land for months, even years, without cooling. One channel, known as Baltus Vallis, meanders for over 6,800 kilometers, nearly the length of the Amazon River. It is the longest known lava channel in the solar system, a scar that tells of forces far beyond anything humanity has witnessed. Yet in all this violence, one puzzle remained. Venus bore far fewer craters than expected. Across its vast surface, only about 1,000 impact craters could be counted. By comparison, the Moon, Mars, and even Mercury were covered with millions. Craters are the timekeepers of planetary history, marking the scars of collisions that accumulate over billions of years. Their absence on Venus suggested something astonishing. The planet's surface was young, not in human terms, but in geological time, perhaps only 300 to 600 million years old. Somewhere in its history, Venus had reset itself. Entire continents, entire landscapes had been buried beneath floods of lava, erasing nearly all record of its earlier epochs. This theory of global resurfacing carried unsettling implications. It suggested that Venus does not simply age slowly like Earth, with tectonics and erosion erasing old features over time. Instead, it may endure long ages of relative stillness, followed by catastrophic events that engulf the planet in molten rock, replacing its surface wholesale. If true, Venus was a world that destroyed its own past, a planet that periodically devoured itself. But the most haunting question was not about its past. It was about its present. Was Venus still alive today? The maps revealed volcanoes whose flows looked fresh, their outlines crisp and unweathered. Radar detected regions where the surface appeared warmer than expected, as if heat still pulsed from beneath. More recent data from orbiting spacecraft hinted at changes in sulfur dioxide levels in the upper atmosphere, a possible sign of volcanic eruptions injecting gas into the sky. In 2020, scientists reported evidence that certain volcanic structures on Venus showed signs of activity in the past few decades. If confirmed, Venus was not only a world of ancient fire, it was still burning. Yet when one looks at the landscapes themselves, a strange contradiction emerges. The images captured by radar, the ghostly photographs from Venera landers, depict a stillness that feels eternal. Flat plains stretching to a hazy horizon, rocks fractured but unmoving, volcanoes vast and silent, waiting in a sky that never changes. Unlike Earth, where rivers carve valleys and forests march across continents, Venus's landscapes appear frozen in time. They are monuments to violence, but violence long since paused. A silence heavy with threat. This eerie stillness is deceptive. On Earth, landscapes are sculpted by the hand of water and wind. On Venus, no such hand exists. There are no rains to erode mountains, no rivers to cut canyons, no glaciers to grind rock into soil. Its dense atmosphere ensures that meteorites rarely reach the surface intact, burning up before they can strike. Change comes slowly, invisibly, until the planet decides to erupt again, remaking itself in cataclysm. To gaze upon Venus is to confront both the familiar and the alien. Familiar, because its mountains, valleys, and plains echo the forms of Earth. Alien, because their origin and fate are driven by forces Earth has never known. It is a broken mirror, reflecting pieces of our world, but shattered into patterns that make no sense. A planet born of the same cosmic dust as Earth, molded by the same laws of physics, yet destined for a path that turned paradise into inferno. And in that reflection lies an unsettling question. If Venus, so similar in size and composition, could become so hostile, what does that say about the fragility of habitability itself? Are Earth's oceans and skies a delicate balance, one small change away from collapse? The landscapes of Venus are not just alien features on a distant world. They are warnings carved into stone, lessons written in lava and fracture. For scientists, Venus remains both puzzle and prophecy. Its coronae speak of hidden plumes pressing upward. Its tesserae preserve echoes of an older world. Its lava channels mark the flow of destruction on unimaginable scales. Its lack of craters reveals a planet that has remade itself in fire. And perhaps even now, beneath the silence of its furnace sky, volcanoes wait to erupt again, reshaping the surface in acts of violence that will never be witnessed by human eyes. The alien landscapes of Venus remind us that worlds are not static. They change, they evolve, they destroy themselves, and in doing so, they reshape the possibilities of life. Venus is Earth's twin in size, gravity, and composition, yet its face tells of a destiny utterly unlike our own. A world that erased its past, that may still burn with hidden fire, that reflects back to us not comfort, but caution. It is both beautiful and terrifying. A planet that shines as the morning star, yet hides a story of ruin beneath its light. Its landscapes are monuments not only to its own history, but to the fragile line every world walks between habitability and hostility. To look upon them is to see a reminder of what might await Earth if balance is ever lost. Venus is a world both familiar and profoundly alien. A broken mirror of Earth's destiny, reflecting not what we are, but what we could become. When the first numbers arrived from the surface of Venus, they read like the statistics of a nightmare. 90 times the pressure of Earth's atmosphere. A crushing weight that would collapse a submarine hull if it were set upon the plains. A temperature of 465 degrees Celsius, hot enough to melt lead and zinc, hot enough to reduce steel to weakness in minutes. Above it all, clouds of sulfuric acid drifting in eternal storms, corroding metal, and choking any hope of survival. These were not the conditions of a sister planet. They were the conditions of an inferno. Every measurement brought disbelief, and yet they held. The Soviet Venera landers confirmed them again and again. The Magellan mission mapped a surface forged in fire. Spectroscopy from orbiting spacecraft revealed a greenhouse effect gone far beyond anything Earth had ever known. Venus was not simply hot. It was a planet trapped in a thermal prison of its own making. The greenhouse effect on Earth is a balance. Carbon dioxide and water vapor trap the warmth of the sun, while oceans, clouds, and forests moderate the heat. Life thrives within that equilibrium. But Venus is the example of what happens when the balance fails. With no oceans left to absorb carbon dioxide, with no cycle of rain to wash the atmosphere clean, the greenhouse effect spiraled out of control. Heat rose, oceans boiled, and the very crust of the planet softened under the weight of its own furnace. It is difficult to imagine that such a world was once thought of as Earth's twin. Their masses are nearly equal, their diameters almost identical. Both worlds formed in the same neighborhood of the solar system, from the same cloud of gas and dust. For billions of years they circled the sun together, close companions in orbit, neighbors in gravity. And yet, while one became a cradle of oceans, life, and thought, the other became a furnace of stone and cloud. The divergence was not fate alone, but physics. Venus orbits closer to the sun, bathing in nearly twice the solar energy that Earth receives. That extra heat was enough to tip the balance. Water, once perhaps pooled in seas or rivers, evaporated more quickly. In the upper atmosphere, ultraviolet light split water vapor into hydrogen and oxygen. The hydrogen escaped to space, leaving the oxygen to vanish into rock and minerals. Without water, there was no regulator, no cycle of rain to cool the air or oceans to trap greenhouse gases. Carbon dioxide, released from volcanoes, accumulated. The cycle fed upon itself. Heat rose, oceans vanished, and the greenhouse effect became unstoppable. In this way, two planets born of the same cosmic dust followed paths that could not have been more different. Earth found balance. Venus fell into fire. The data revealed more than just a hostile planet. It reshaped planetary science itself. Before Venus, habitability was imagined as a broad zone around a star, a wide belt where temperatures might allow liquid water to flow. Venus proved that habitability was not only about distance. It was about balance, feedback, and fragility. A planet only slightly closer to the sun than Earth had become utterly uninhabitable, not because of its distance alone, but because of the runaway chemistry of its air. This lesson reverberates across the study of exoplanets. Astronomers now search distant stars for Earth-like worlds, but every world is a delicate equation of light, gravity, and atmosphere. Venus is the cautionary tale, the reminder that habitability is not guaranteed even when a planet looks like Earth's twin. A world can be the same size, the same mass, and still diverge into a furnace. The weight of Venus's atmosphere itself is a revelation. At 90 bars, standing on its surface is like standing a kilometer beneath Earth's oceans. To send a probe into such an environment is to pit human engineering against a world determined to crush and melt. That any machine survived at all is a triumph of persistence. And in those brief moments of survival, they transmitted truths that transformed human understanding. For scientists, these numbers are not merely statistics. They are insights into the forces that shape planets. Pressure, temperature, radiation, convection, these are the universal laws of thermodynamics and gravity playing out on a planetary stage. Venus is the laboratory of extremes, showing what happens when the same rules that govern Earth are pushed to their limit. Albert Einstein once described the cosmos as a fabric woven by the laws of physics, where gravity bends space and time itself. Stephen Hawking spoke of inevitability, the way entropy and thermodynamics move forward, reshaping matter and energy without pause. On Venus, their insights are not abstractions but realities. Gravity binds the atmosphere in place, holding its crushing weight against the surface. Thermodynamics ensures that once the greenhouse effect began, it fed upon itself until stability was lost. Entropy is written into its landscape, a record of oceans boiled away and a surface renewed in cataclysm. To contemplate Venus is to confront inevitability. Planets are not static jewels in space. They are living systems, governed by physics, driven by cycles of feedback, fragile in their balance. Venus teaches that a small difference in distance, a slight shift in climate can tip an entire world into ruin. And yet, there is beauty even in this inferno. The clouds, though filled with acid, shine in golden light when seen from space, reflecting the sun in brilliance. The surface, though scorched, is sculpted into landscapes of mountains, domes, and valleys that rival Earth in grandeur. Its fate is tragic, but its reality is profound. The story of Venus is not only about what it is, but about what it means. For Earth, it is a mirror of possibility. It shows how a planet so similar in birth can diverge so drastically. It is a warning, yes, but also a guide, a reminder of the fine line that defines habitability. In the silence of space, the data from Venus speaks with a voice of caution. It says that planets are fragile, that atmospheres are not eternal, that oceans can vanish and balance can be lost. It tells humanity that the habitable world beneath its feet is not inevitable, but a gift that must be understood and protected. Einstein's vision of cosmic law, Hawking's vision of inevitability, they are written into Venus. Gravity holds its furnace sky in place. Thermodynamics drives its greenhouse effect into runaway extremes. Entropy ensures that its surface bears the scars of catastrophe. And yet, in their inevitability, there is also revelation. For to understand Venus is to understand not only how worlds die, but how they live. The data that once read like the statistics of a nightmare is now the foundation of wisdom. Pressure, temperature, atmosphere, geology, all conspire to create a world alien and hostile, yet also deeply instructive. Venus may never be a place humanity walks upon freely, but it will always be a place humanity learns from. For in the end, Venus is not only a planet, it is a story written in physics and fire. A story that tells us that even the closest of twins can grow apart, that balance is fleeting, and that the fate of a world is never guaranteed. The question lingers like a shadow behind every image and every number drawn from Venus. Could there have been life? It is not a casual question. It is the oldest one humanity asks whenever a world reveals itself, whether the barren moon, the dusty plains of Mars, or the icy oceans of Europa. But when it is asked of Venus, the question carries a deeper weight. For Venus is not a distant moon or a frozen ocean. It is Earth's twin, a planet so similar in size and origin that the idea of its lost oceans feels less like speculation and more like a haunting memory of what might have been. Clues whisper of that past. Climate models suggest that billions of years ago, before the runaway greenhouse took hold, Venus may have had shallow seas. Not oceans like Earth's, but vast enough to blanket its surface with water. For as long as 3 billion years, conditions may have lingered in the habitable range, long enough, perhaps, for life to begin. Long enough for chemistry to cross that fragile threshold into biology. The idea is not without evidence. Traces of deuterium, a heavy isotope of hydrogen, linger in Venus's atmosphere at far higher levels than on Earth. This enrichment hints that oceans once evaporated and vanished, their lighter hydrogen escaping into space while the heavier atoms remained. If true, Venus did not always burn. It once may have flowed with rivers and lakes beneath gentler skies. If life did begin there, what forms might it have taken? The speculation turns not to creatures or forests, but to the smallest and most enduring architects of habitability, microbes. On Earth, microbial life has been found thriving in volcanic vents within the ice of Antarctica and in clouds high above the ground. If Venus once had oceans, microbial life could have swum in its waters, shaping its chemistry, living in warmth before the climate turned. But when the greenhouse rose and the oceans boiled away, what then? Did life vanish with the water, its fragile beginnings lost forever? Or did some forms adapt, retreating to niches that remain less hostile even today? High above the inferno, within the thick clouds that encircle the planet, temperatures are far cooler, hovering between 30 and 60 degrees Celsius. Pressures there are closer to Earth's own atmosphere. For decades, scientists have speculated that if any life persists on Venus, it could drift in those clouds, tiny microbial organisms clinging to droplets of acid, surviving in an alien sky. The speculation gained a new pulse in 2020 when a team of astronomers announced the detection of phosphine in the Venusian atmosphere. On Earth, phosphine is produced by microbial life or by industrial processes, and its presence elsewhere is difficult to explain without biology. The finding ignited debate. Was this a true biosignature, or could volcanic chemistry or unknown processes generate it? The data was contested, the signal faint, the interpretation uncertain. Yet the announcement stirred imagination. For a moment, humanity wondered if the morning star might not be silent after all. Whether the signal holds or not, the philosophical tension remains. Venus is not only a scientific puzzle, it is a mirror of lost possibility. It shows what happens when a planet so like Earth diverges, when seas vanish and skies turn to fire. To imagine life there is to imagine a parallel Earth that could have been, and that never was. If microbial life did once thrive on Venus, its story ended not with extinction alone, but with a planetary shift so complete that it remade the very identity of the world. In this way, Venus embodies both hope and tragedy. Hope, because it shows that life may arise wherever conditions allow, even on planets that later become hostile. Tragedy, because it shows how fragile those conditions can be, how easily they can be lost. In the silence of its present-day landscapes, that possibility endures as a ghost. Venus could have been Earth. It could have been a blue planet shining with seas and clouds, its skies alive with biology. Instead, it became a furnace. And perhaps, in that divergence, it reflects the precariousness of life everywhere in the cosmos. The search for answers is far from over. Future missions now prepare to return to Venus with tools far more powerful than those that came before. NASA's Veritas mission will orbit the planet, using radar to map its surface in unprecedented detail, searching for signs of active volcanism and tectonic change. Da Vinci Plus will plunge into the atmosphere, sampling its gases directly, measuring their chemistry, and seeking the fingerprints of water once present. Together, these missions may reveal whether Venus ever had oceans, and whether its clouds hold secrets yet to be uncovered. Other probes, from Europe, India, and Russia, are being planned as well. Each carries the same unspoken question: was there ever life? Did a world that now burns once shimmer with rivers and lakes? Did microbes thrive there before fire claimed the planet? If the answer is no, Venus still teaches us. It teaches that habitability is fragile, that climate can change a planet beyond recognition. If the answer is yes, if even the faintest trace of past biology is found, then Venus transforms from a cautionary tale into a revelation. It means that life is not rare. It means that given time, given oceans, given the smallest chance, biology emerges, even on worlds that later fall into ruin. The pursuit of this question is more than scientific curiosity. It is existential. For in the fate of Venus lies a reflection of Earth's possibilities. Venus reminds us that oceans are not eternal, that atmospheres can shift, that climates can collapse. To ask if life ever thrived, there is to ask whether life can ever endure anywhere, or whether the destiny of all living worlds is eventual silence. Venus is the morning star, the brightest light in the night sky, a constant presence in human history. For millennia, it has been a symbol of love, war, and divinity. But its true story may be deeper still. It may be the story of a world that once knew life, then lost it forever. A parallel Earth that fell, leaving only heat and stone where once there may have been seas and sky. And so the question remains, could there have been life? Did Venus carry the spark of biology before the greenhouse claimed it? Does it still cling to the clouds in forms too small for human eyes? Science may not yet know the answer, but the pursuit of that answer is part of what makes the mystery of Venus so haunting. For in seeking it, Humanity is not only asking about Venus, it is asking about itself, about the fragility of Earth's balance, about the possibility of life elsewhere, about the future of worlds that orbit stars. Caught between habitability and ruin, the upcoming missions will probe the skies, scan the surface, and measure the chemistry of a world that has kept its secrets too long. Perhaps they will find nothing. Perhaps they will find hints of oceans past. Perhaps they will even uncover evidence that biology once stirred beneath its clouds. Whatever they discover, Venus will no longer be only a planet of speculation. It will be a planet of answers. Until then, Venus stands as the most haunting of mirrors, a world that might have been Earth, a world that might have known life, a world that shows in its silence and its fire how fragile the gift of habitability truly is. For millennia, Venus was a mystery draped in brilliance. It rose before dawn and after sunset, the morning star and the evening star, its radiance inspiring gods, myths, and dreams. Humanity worshipped it as divine, imagined it as paradise, and longed for the day when the veil would lift. That day has come. After centuries of speculation, we finally know what lies beneath the golden clouds. And the truth is stranger, harsher, and more profound than the imaginings it replaced. Beneath the veil is no paradise of oceans and forests. It is a furnace of stone sculpted by fire and crushed beneath an atmosphere so heavy it would flatten steel. It is a world where mountains rise higher than Everest, where lava flows longer than the Nile, where the air is poison and the ground seethes with heat. A planet both magnificent and merciless, both Earth's twin and its dark opposite, and in its revelation lies a story of hubris. For centuries, humanity painted its own hopes onto Venus's hidden face. Telescopes showed only light and shadow, and into that silence we poured visions of jungles, oceans, even civilizations. We mistook ignorance for possibility, and our imagination filled the void. Yet when science pierced the clouds, the planet revealed not our dreams but its own reality. In that moment, humanity was reminded that the universe is under no obligation to mirror our desires. The cosmos is what it is, not what we wish it to be. Still, the act of piercing the veil was not wasted. To seek truth, even when the truth destroys our illusions, is part of what it means to be human. From Galileo's telescope to the Venera landers, from Magellan's radar to today's missions, the pursuit of Venus was never only about finding paradise. It was about refusing to look away from mystery, even when the answer might be harsh. It was about daring to ask questions whose answers could unsettle the very foundations of our imagination. In the landscapes of Venus, humanity confronts a paradox. The planet is Earth's closest twin in size and composition, yet it is also our most extreme contrast. Two worlds born of the same dust and orbiting the same star, but separated by a single fate-altering divergence. Earth found balance. Venus fell into fire. In its broken beauty, we glimpse both warning and wonder. The warning is clear. Venus is a mirror of possibility, a demonstration of how quickly habitability can be lost. Its runaway greenhouse effect shows what happens when equilibrium collapses, when oceans vanish, when air itself becomes a trap. To study Venus is to see, writ large across the sky, the fragility of Earth's own balance. It is to understand that climate is not permanent, that habitability is not guaranteed, that the gift of oceans and breathable air is both precious and precarious. But alongside warning, there is wonder. Venus is a reminder that worlds are not static, but alive with change, shaped by forces beyond imagination. Its mountains and domes, its tesserae and lava plains, its clouds that glow with golden light, all are part of a cosmic story unfolding on scales larger than human life. To gaze upon Venus is to see the creativity of nature expressed in extremes, to witness the power of physics and geology at their most uncompromising. It also reflects something deeper about humanity itself. The need to peer beyond veils, to pursue mysteries even when the answers are painful. For in the act of discovery, we are changed. The disappointment of lost oceans becomes the revelation of planetary destiny. The silence of its barren plains becomes the voice of warning for our own future. Even in harsh truths, meaning emerges. Einstein once said that the most incomprehensible thing about the universe is that it is comprehensible. Hawking reminded us that to look up at the stars is to glimpse our own origins and fate. In the clouds of Venus, these reflections find their echo. A world once imagined as paradise has shown itself as ruin, yet in that ruin we find comprehension. We see the laws of thermodynamics, the inevitability of greenhouse feedback, the imprint of entropy upon a planet's face. And through that understanding, we find meaning. Venus teaches us that Earth's story is not inevitable, that oceans are not eternal, that climates can change beyond recognition, but it also teaches us that knowledge is possible, that truth can be revealed, that even beneath the harshest veil, science can find light. And so, the pursuit of Venus does not end in despair. It ends in reflection. For if the morning star can fall into fire, then Earth's balance is more fragile than we might wish. Yet if we can look upon Venus and see both its ruin and its beauty, then perhaps we can also look upon Earth and see both its gifts and its responsibilities. Venus is no longer a mystery of myth. It is a story of revelation written in clouds and stone. A story that tells us who we are, what we dream, and how fragile our place in the cosmos truly is. The clouds parted, and beneath them we did not find paradise. We found truth, and in truth we found meaning.